Oil and gas operators are turning to passive monitoring technology to improve well stimulation results and avoid environmental hazards. As the pioneer in passive monitoring, with over 10 years of experience, MicroSeismic helps oil and gas companies understand how their reservoir responds to stimulation. Patented PSET processing technology accurately images microseismic events that occur as a result of stress changes in the subsurface. The FracStar surface array is temporarily deployed during the period of the fracture job to collect data. The results help improve completions, determine optimal well spacing for field development, and assure environmentally safe well stimulation. FracStar's flexible design enables crews to work around impeding structures, varying topography, permitting considerations, or other challenges. Our sensors have proven reliable in the most extreme weather conditions. FracStar acts like a stethoscope, passively listening to the sounds from the subsurface. There is no need for large, heavy, vibro-sized trucks or dynamite sources typically used in active seismic operations. Each FracStar array is deployed by a team of professional crews with minimal intrusion to the property. The crew's top priority is protecting the land and ensuring environmental sustainability. The use of our tiny sensors ensures a minimal surface footprint. Here we see a series of stations being laid out across the arm of a FracStar, which tracks the horizontal wellbore below. Crews quickly deploy the temporary cables with a set of sensors strung together into stations along the designated FracStar arm. Each array contains approximately 10 to 12 arms distributed radially around the wellbore, with anywhere from 100 to 120 stations per arm. Acquisition geometry is resilient to surface obstructions because the stations can be laid out to avoid hazards. Now the well operator can begin stimulation activities. As the rock breaks, the resulting sound propagates to the surface, where the sensors detect the sound waves. The analog recording is digitized and transmitted to the recording truck. Crews in the recording truck begin monitoring the acquisition of data during the stimulation treatment and beyond, as required by the monitoring objectives. Here we show a 7-well multilateral being monitored in the Marcellus. As the rocks in the reservoir begin breaking during well stimulation, data is gathered from the sensors and mapped to show where the fractures are occurring. The dots represent each point where a rock is breaking, and the different colors indicate the individual stages. The same results are being displayed on the right side of the screen, but in this perspective, it is possible to see the fractures are contained within a few hundred feet from the wellbore, which, in this case, is 9,000 feet below the surface. This is important because it contradicts a common misconception that fractures can propagate thousands of feet towards the surface, causing water contamination. In addition, real-time monitoring means that pressure pumping activity can be shut off should the need arise. The results shown here help the operator realize that by increasing their well spacing, they could reduce the number of wells to be drilled, saving hundreds of thousands of dollars and significantly reducing their overall environmental footprint. One of the great byproducts of this technology is that it provides transparency to the well stimulation process, assuring both operators and landowners that fracturing is being done effectively and safely. After the job is complete, our crews retrieve all elements of the array from the property. The recording truck is moved off to the next job, leaving virtually no trace and no environmental footprint. Our skilled teams of geoscientists and engineers conduct additional interpretation of the data to derive fracture models and ultimately estimate well productivity, all delivered less than a month after the job. The surface FracStar, along with the near-surface buried array and downhole monitoring array, comprehensively provide operators the ability to choose the best technology for their needs. This is why more companies trust MicroSeismic Incorporated than any other for passive monitoring and analysis of hydraulic fracture propagation, reservoir change monitoring, and seismicity detection.